Oh, okay. Good afternoon, everyone. And today, my pleasure is to introduce Kenneth Benoit. Kenneth is a rare breed of a scientist who is actually joining the academia and industry. He's known as a developer and the leader of quanteda, which is one of the fastest packages in R for text processing. But also Ken is known as being a scientist. As a scientist, right now he's right now he's right now he is working in the London School of Economics. He is a director of a new institute of data science. So I suppose there are a lot of openings both for PhDs and postdocs, isn't that, Kenneth? So if you are willing to work in a great atmosphere in ever open London, I think the Data Science Institute is a great place to start or kickstart your data science career. Okay, thank you, Kenneth, for joining us. Kenneth is an old timer of YR. He was with us in Warsaw 1 year ago, and we are extremely happy that he's joining us during our hackathon. I hope everyone is. I hope that we have also some participants from the hackathon. So, without much further ado, Kenneth, the floor is yours. Thank you.
Thank you very much for that introduction. I'm very happy to be here, and I think it's super cool that the hackathon is about text analysis. I'm going to talk to you about some tools for text analysis. So my talk today, if I can get this in presenter mode, there we go. Okay, you shouldn't be seeing that. Hang on, maximize, there we go. Right, so my talk today is called Why You Should Stop Using Other Text Mining Packages and Embrace quanteda Now. Now, I'm going to explain why I chose such a title. I was an editor of a major academic journal for 4 years that just ended a few months ago. I got a little bit burnt out on dry academic articles. So I'm going through a phase where I'm choosing articles that are a little bit more clickbaity. It'll probably pass. I could have thought some other titles. I thought, what about what these YR participants have discovered about quanteda will surprise you? Or stop making these R text analysis mistakes now. I've actually given that talk. Could have said why many Python NLP users are making the switch to R. Or how about text analysis using R secrets that the Tidyverse fans don't want you to know? I'm sure I'll get a lot of questions about that. And I'm going to leave plenty of time at the end of this talk for questions. I'm happy to take your questions. So let me explain a little bit about what quanteda is. You might have been using it for the hackathon. If you are, great. If you want to provide feedback, we love feedback. And I'm going to be explaining about one of the reasons why you'd want to use quanteda. It's a very, very well supported ongoing project. So what is quanteda? Well, quanteda is an open source quantitative text analysis tool in R. And it stands for the quantitative analysis of textual data. There should be an "of" in there, but that's what quanteda is for, because it's about treating text as data. And I've written academic articles about what this means to treat text as data, but it essentially means that we're interested in the text because it tells us information about the world that is represented in that text. If we were reading literature, and you can use quanteda for analyzing literature, but if you're reading literature, you're interested in the text as a text. Of course, there are a lot of theories about how to study literature, and I'm not one of those scholars, but you're interested in the text itself versus, say, what the text would tell you about something. So if you're analyzing customer reviews, you're interested in the customer satisfaction about your product and how people perceived its usability, its durability, how it looks, etc. You're not interested in a linguistic exercise of analyzing that text. The text is just a useful supplement for getting other information. And that's exactly what the package is designed to do. So I started developing this project in 2012. I was supported by the European Union through a European Research Council grant, and that got the project going. And it developed into this project that is ongoing now through independent means, and I'm going to be explaining what that is one of the reasons to continue using the package. We developed quanteda for high consistency and high performance. We wanted a combination of good design, usability, and high performance. So many of the core functions are written in C++. These are multi-threaded at the basic level using Intel threading building blocks for multi-threading. So it's multi-platform, genuine low-level multitasking or multi-threading, so it can use all the threads in the cores of your CPU. It's faster than a lot of other R packages. It's certainly faster than TM, and for many things that you could try, it's faster than tidytext. And according to Kohei, who's always running tests, it's faster than Python packages like Gensim. It's also fully multilingual. So the way that it implements text and the Unicode handling, it works very well with other languages, including languages like Chinese, Japanese, and Korean. We have tutorials, in fact, written in Chinese and using Chinese languages to show that this is true. And as you'll see, a lot of my development team, their native languages are these languages. So quanteda is a standalone package, but it's also designed to work very well with other packages as a framework. So we have a growing number of reverse dependencies that are other packages built around quanteda, and we're actually going to be modularizing it further to make this even easier to use quanteda as an NLP engine for other packages. So let me start with the reasons. I think I have 6 reasons. And I've organized this talk very simply to just go through the reasons. So what's the first reason? Well, this is an easy reason. This is a reason I don't need to explain to this audience. It's written in R. This is not a conference about Python or Java or anything like that. It's about R. So I'm preaching to the choir when I give these reasons, but basically you have native data objects in R that make it unnecessary to have additional libraries. For example, if you're using Python, you need something like a data frame, you need packages like pandas. And you don't need that in R because the core objects around which text analysis package can be built are built into the very DNA of R. This allows them to have better integration across the whole package ecosystem of R. It also facilitates quantitative analysis directly, and that's what quanteda is designed to do, to turn qualitative text into quantitative information for analysis. ggplot2. Great reason to use R. I saw some discussion yesterday about the various Python plotting libraries versus ggplot2. I am on the side of ggplot2. The tidyverse. The tidyverse has revolutionized the usability of R. I'm a big fan of the tidyverse, and I've even got a package called quanteda tidy that's in production to allow direct use of most of the dplyr functions and some of the functions for reshaping objects on quanteda objects directly. So, and RStudio, I mean, who doesn't love RStudio? It's my favorite IDE of pretty much any IDE I've ever used. It's wonderful. And the guys at RStudio are brilliant in supporting and innovating and just serving the community. So these are all wonderful reasons to do that. Okay, that's reason number 1. Reason number 2 is that it does everything, and it does it with an awesome design. And I'm going to brag here because we are very proud of the design of quanteda. One of the criticisms we occasionally see is someone who will say, this code no longer works. Well, that's because when we got up to version 1, which was about 2.5 years ago, we broke some things after really reconsidering the design that we wanted to be the basic framework for all the commands. And we weren't really happy with it. So after many, many discussions, we settled on a design that we have at the moment. Now, when I talk about design, let me walk you through what I think is what I call this text analysis simplified. When I teach this in my courses, this is basically what I teach, to demystify text analysis. And I probably don't need to tell you guys if you're at this hackathon, but you start with raw text. You turn the raw text into quantitative data. This involves tokenizing the text, segmenting the text based on some criterion. Usually it's white space, but not always white space. When we separate punctuation characters that's not always delimited by white space. There are some languages don't use white space separations in between words, like Chinese. Then we do feature selection to select the tokens that we want. We might get rid of stop words, etc. We might weight them. We might threshold them. And then we turn this into a matrix representation. This matrix representation is essentially the quantitative representation of the text that we started with. And once we have that, we can compute anything that we can do with the matrix, we can compute on this information. Now, I'll qualify that shortly, but essentially we can compute statistics on this. We can compute special statistics that are designed for text, such as readability or lexical diversity. We can do similarity matrices. We can do distance matrices, which allow us to do clustering. We can compute scaling for sentiment analysis, and then we can apply a variety of machine learning models. And I know that's a key part of the hackathon, doing supervised and unsupervised machine learning. Scaling, we can compute word embeddings. We can use those word embeddings in our models. We can estimate topic models. And of course, there's a lot of graphical representations of data. And Julia did a really good job yesterday of explaining and showing some of the graphical representations. So this is the process that we wanted quanteda to enable in text analysis. So it's built around a set of core objects. These core objects each have a constructor, and then they have a series of functions that operate on objects that have been constructed using that function. So for example, to create a corpus in quanteda, which is a collection of your documents, it's a single object that not only collects your documents, but also collects additional data related to those documents, what we call document variables, and also metadata, maybe at the corpus level. We use the corpus command, and that takes the inputs, which is usually some vector of text, but could be data frames, could be a TM corpus, could be some objects that are from tidy text, and it creates a quanteda corpus. And the resulting object is classed as a special type of object known as a quanteda corpus. You can do the same thing for tokens. So this tokenizes the text and basically indexes a series of texts that are represented under the hood as an efficient numerical object with representations of the tokens in a type of lookup table. And this makes it very efficient, especially when we do processing. But to the user, it basically looks like a list. We also have constructors for creating matrix objects, such as DFM, which is to create a document feature matrix, which is my terminology for what we call the term document matrix, although we don't allow term document matrices because the terms should be in columns. The terms are features of the unit of text, which is a document. We made a decision long ago, that's the only way you're going to get the matrix in quanteda. Keeps things simple. A feature co-occurrence matrix is the sort of thing that you would input, for example, to estimate embeddings. It's where you get a matrix of local co-occurrences of one feature versus another feature. There is a constructor for dictionaries that allow you to import word lexicons or word lists that can be valenced. They can have scores for sentiment, or they can just be associated with categories like positive or negative, or pretty much anything else that you want. There are a set of functions to compute statistics that start with the word textstat with an underscore. There are a series of models that are now in a separate package called quanteda text models that start with text model underscore. And then there are a set of plotting commands that are basically called text plot underscore that do various plots. So if you are looking for a function, you'll know exactly in the index where to go to look for that function. So one of the things we wanted is not to have an index of all the functions in the package where you really had to figure out, is this a data object? Is this a function? What the hell is this? It's going to be obvious from the terminology, and it's going to be organized. We also have a series of functions that we've extended from basic R syntax that would be familiar to you if you're an old school basic R user. These are functions that everyone uses. To get the number of rows from a document that is matrix-like, you use in row. It's not in rows, it's not num rows, it's not camel case, it's in row. Well, we thought, okay, let's extend that. To get the number of documents in any object that has documents, we'll call it in doc. Not in documents, because in call is truncated, right? So it's like a logical test here to try to extend the language in the most similar way possible. They're all singular, but we have in token, in doc, and other things like that. And they make sense to you if you're an R user. So the way we organize the functions for each, and I'm not going to go through everything, but just to show you how it's organized. We have this issue in R. This is one of the weaker points of R, is the object orientation system. And I know that there are about 3 or 4 in use. quanteda is written in a combination of S3 and S4, but the user doesn't need to know much about that. When you create a corpus object, it creates an object of class corpus. We ended up not overclassing a series of generics. We created the generics that, through their nomenclature, would be very obvious as to what they do and what they take in and what they put out. Any function that is corpus underscore anything, which is going to be a verb, takes a corpus in, modifies it, and outputs a corpus. And there are no exceptions to this. So all the functions for manipulating tokens are tokens underscore. All the functions for manipulating a DFM are DFM underscore. And the same as I'm showing you here for corpus. They always take a corpus in, modify it, output a corpus. And that way you've got sort of a belt and braces approach to object orientation. So we have functions for doing reshaping, for resampling documents, for segmenting documents into more documents, for extracting subsets based on Booleans, or I should say logicals in R, and these can be from document variables that are associated with the object itself. For trimming things, if you want to get rid of short documents, there are a lot more functions, and these are all growing all the time. For tokens, we've got functions to manipulate tokens, like compounding multiple sequences of tokens into a single one. This is great if you have a lexicon of multi-word expressions and you want something like European Union to be compounded as a single token. You can send it a list and it will just do that, and then suddenly they become single tokens. This is really, really useful for creating valid predictions and valid analysis, especially in social science settings. We have a lookup function. Lookup functions look at a dictionary. They count the number of words that occur in dictionary categories and create a document feature matrix that consists of counts, not of just the features as they're found, but of the features as they match a dictionary key. These are great functions for manipulating dictionaries and using them. There are functions for selecting and removing tokens. So let's say you want to get rid of all hashtags. You can use a wildcard after the hashtag symbol and remove all tokens that start with that symbol. You can do this for regular expressions. You can do this for what we call simplified regular expressions, or globs. And you can do this for fixed pattern matches, of course. And on something that we have in production, we're going to allow people to select on parts of speech as well, but that's not implemented yet. There are functions for creating n-grams or skip-grams. These are all written in C++. They're super fast and super flexible. Of course, we have case conversion functions. We have word stemming functions, and there might be 1 or 2 more in the package. There are functions with DFMs for creating groupings. This is a really useful one. So I deal with the speeches of members of political parties. And I might have, I don't know, in the House of Commons, 650 members of parliament, and I have all their text, but I also have a variable which tells me which party they're from. With one command, I can create the document feature matrix, which will have 650 documents and a ton of features, into, say, 5 or 6 parties by using the grouping variable, which just combines them based on that grouping variable, in this case, political party. That's a really useful function. Lookup, we can also use dictionaries directly on DFMs. We have the same selection and removal things using the same syntax. They operate on DFMs as well as on tokens. Trimming based on frequency threshold feature selection. So getting rid of low frequency words, or words based on document frequency, or words based on some proportion. This is a very flexible and very fast command. We can do weighting. So we can weight based on TF-IDF, based on all the schemes that are found in the textbooks on statistical language processing. And we can word stem a DFM. If you haven't done it already, you can do it at that stage. And you can also use FCM to create feature co-occurrence matrices. We have text statistics for computing collocations. So what is the statistical association of one word found in front of or behind another word, which helps you find multiple basically multi-word expressions. We can compute distance. We can compute keyness. Keyness is basically the association of a word with a particular category. So if I have positive and negative movie reviews and I want to find out the most negative and most positive words, keyness is our tool. Lexical diversity tells us something about the vocabulary usage. Readability, so I think this is the best implementation of readability statistics you'll find in any software. And I know because I programmed every one of them myself, and I went back to the original papers and tried to implement everything that they wrote, even when these papers were written in 1948 or 1950 or something. It wasn't easy. I kept making corrections, found a lot of mistakes in other people's software. And every one of these functions is documented with a bibliography in a kind of academically respectable, scholarly way. So this is not, some engineer who's read one paper and written something that works good enough for what their purpose is. I was trying to basically hold up under assault from super smart people who know a lot about readability in various fields. If they wanted to pick this apart at the atomic level, I wanted it to hold up to that scrutiny. That's what open source is about, and that's what science should be about. So one of the things that you can trust about quanteda, and when we implement something like this, we're a little bit conservative about what we implement, but when we do implement it, you can trust that it's implemented pretty correctly. Similarity computation, there's also one for distance. So if you want to compute cosine similarity, we've got an extremely fast cosine similarity computation function. In terms of text models, these are now in a text models package. So we can compute correspondence analysis, latent semantic analysis. There's a naive Bayes classifier. There's a very fast linear SVM classifier. There is now penalized logistic regression for text. So this is a wrapper around GLMNet, but it's built for basically binary classification of text. And then there are some models that I've either created myself or have colleagues that have created that come from the academic field where my research started, which is political science. These are scaling models that might not mean anything outside of those texts, but the articles are there, and they work really well in the areas where they've been applied. We've got some visualization functions. We have, I think, 4 visualization functions at the moment. We're working on a new one, and we're always interested in more. And these are modular. So anyone who said, I've got a function, write a wrapper around it, I want to contribute this, we can add this. These functions know which object they need. So text plot keyness requires an object that's been computed through text stat keyness, and then it produces that. And word cloud produces word clouds based on either a document feature matrix or a keyness object. Now, it'll give you a word cloud, comparison word cloud of the most negative and the most positive words, or whatever your target and reference set were in keyness. That's reason 2. Reason 3, it's damned fast. How fast is it? Well, it can do the Kessel run in 12 parsecs. If you're a Star Wars nerd, you'll know what that means. Well, why is it fast? Because we're obsessed. Yeah, we're obsessed. So if I ever want a function to be faster, I just tell my main collaborator on this project, Kohei, and I say, Kohei, this function's kind of slow. Or Kohei, this other package has a faster version of what we do. I'm guilty of that one too. When I find out someone else is faster, we just obsessively rewrite it until we're no longer slower than they are. There's a lot of C++. There's a lot of core. For the core tokens, most of that is handled in C++ underlying the workhorse regimes. And a lot of the routines and a lot of the functions that are statistical are now moved to C++ as well. We've also parallelized this code. So if you turn on multi-cores, CRAN only lets us turn on 2 cores. So the version that 99% of the people are using is actually a lot slower than it could be, because you've got to turn on that as an option, and you can set that in your R environment file or whatever, so that R profile, so that every time you start it, you get quanteda, give it most of your cores, and it'll be much, much faster. We use the magnificent stringy package for vectorized C++-based character and regex handling. And all of the this is really important, all of the objects that operate, all of the functions that operate on our DFM objects use only the sparse space. So we only deal with the cells that are non-zero. And the typical document feature matrix will be about 90% empty. It's not just that you're going to be 10 times faster for some of these functions, linear complexity. Most of them are non-linear in complexity. So you have things that are many, many times slower, like orders of magnitude slower than they would be if you tried to treat this as a dense matrix. And there's also the problem, of course, that as a dense matrix, you may not be able to even fit it into memory. So it's really, really important to do everything sparse. And when people are surprised at how quick the routines are in quanteda, it's not just the vectorization, the C++, and the multi-threading. It typically starts with the fact that our operational matrices always keep the object sparse. We also map tokens to a lookup table, which basically means we're dealing with numbers in integer map, and this reduces memory usage also significantly. And I've already mentioned the parallel computation. And this is a good, robust multi-platform parallelization using RCPP parallel, and it's much more efficient than doing it in R through the various solutions available. These are some plots that show what it's like when you run it and you're monitoring your cores, and it's kind of cool because you see everything go and your computer starts to heat up and it spits out the answer really fast. Reason number 4, great support. So there is a lot of documentation now on quanteda. I'm working on a book with Kohei. It's just coming really slowly. I really envy Julia's ability to produce these books. I think I was working on my book before she even started the Tidy Text book. That's how slow we are. But when we do finish it, it's going to be comprehensive. Quanteda has also changed like 2 major versions since we started that. We're working on a YouTube channel. We've got a tutorial site. I saw that Kohei was just updating that this morning with penalized regression examples. We've got a blog with some growing examples. It's now on our bloggers. And we've got this documentation site, which is a big package down site. And I'm going to be working on instructional videos and getting used to this whole, I don't know, streaming. We're thinking of even having like every 2 weeks having something called Ask Us Anything live, taking questions. We're probably going to be trying those soon and seeing how they go. So you can see the constant development. If you look at the GitHub, the histories of commits, you'll see that this is a really, really active project. We've dealt with over 2,000 GitHub issues. We have a Stack Overflow channel. I usually answer those questions really quickly. When I want to avoid more tedious work, I sort of open up Stack Overflow and answer a few questions. It kind of gets my mental juices flowing. And we also love contributions. We love it when people give us feedback. We love it when people, even better, fix stuff or suggest code or contribute code. And you'll see on the quanteda project, the number of people listed as collaborators is very long. You know, we're academics and we give credit, we cite, and if you wanted to be a part, you know, we're not trying to be precious about who contributes. The more the better. Subject, of course, to Kohei and I having absolute dictatorial control over anything that goes into the package. Should add that small caveat. We're currently in version, this is very old. We're currently in version 2.1.2. It was just published yesterday, I think. And it'll have to change soon because apparently we're not passing the test on Solaris, everyone's favorite vintage operating system. Very hard to test for Solaris when you're doing things with Unicode. But we're on 2.1.2. We reached a major milestone earlier this year when we turned 2.0. And that was a major overhaul of the way that the infrastructure worked. And it really, really improved performance. What are we planning to do? We're planning to parallelize tokenization so that it should be easily parallelized. What we actually did in 2.0 was we moved away from trying to do all the tokenization on our own, and we made it easier to use other tokenizers such as Spacey or SpaceyR, which is another package that I support, or the tokenizers package on which I'm a co-author. So if you want to use those other tokenizers, then we can create a tokens object from anything that looks like a list or a data frame, or from a tidyverse tokenization object. Those work really well. But we have a built-in tokenizer that's a little slower than those, but it's very smart. And we designed it to be smart. Our thinking is you're only really going to tokenize once. And once you've done that, then you can save that object and you don't need to do it again. So the speed of tokenization is not where that concern. You can do it really fast if you want, but I'd rather be smart than fast when it comes to segmenting the text. We're also working, I've got a package called quanteda.sentiment, and we're having some design debates over sentiment analysis, which has got me reading books on sentiment analysis and papers and trying to really get this right. But if you're interested in sentiment analysis and you want to use quanteda for it, check out the package, quanteda.sentiment. It's on GitHub, and we'd love your feedback. We're working on more plots. This is a really important one, about keeping track of parts of speech and entities that are annotated from something like SpaceR or the UDP pipe package. These are part of speech taggers, and they keep track of additional information about words that would otherwise, and English is a really bad language for this. You have two words that are written exactly the same, but they're different words. And there should be a way to keep track of the fact that two words that are homographs, they're written the same, are actually different parts of speech and therefore different words. We've got the quanteda tidy package, which is getting there. It's fairly complete, but needs some user feedback. And I think I wrote that over the summer during lockdown. We got machine learning integration with tidy model. So this is a big one. I'm really looking forward to the development of the tidy model package, because we have a sort of manual approach which contrasts to everything else we do in quanteda, which is let's figure out once and for all the most efficient and the most correct way to do something. Let's package that, and then let's make that available so that you don't need to read a blog post that has this much code and takes you half a day in order to implement something which we can give you in one function. That will be more efficient and correct. And if you want to quibble about whether it's correct, you can look at the source code file issues and we can have a debate, but you don't need to re-implement the wheel. You won't have that glow of satisfaction of having figured out, how to do something in 100 lines of code. You'll have done it in one. But with tidy models, so with our models, you basically fit your object, and then you need to do some of the cross-validation and other performance metrics. It still requires a bit of programming. So we're going to try to package that up to make that as easy to use as everything else. And I think the tidy models, we started to do that with the carrot package, but tidy models is taking over from that. So we're going to wait and see and work on that. That'll be one of the projects over the next 6 months or so. This is our core team. So here are, this picture was taken a few years ago now, but that's me, and that's Kohei next to me. And then there's some other people who worked on the project. And I didn't realize this until the last time I presented this, but yeah, we've actually got a pretty diverse group there. And a lot of people whose native language are some of these harder languages. So we really want to make this international. And because my co-authors know a lot about those languages, I don't, unfortunately, it does work well with that. And the last thing I'll say about the support is we actually formed a nonprofit organization. It's called a community interest company in 2018 called the Quanteda Initiative. And we have, I'm a Lost fan, if anyone remembers that show. So we've got a logo that looks like the Dharma Initiative. We offer training events. We offer published documentation and hopefully soon videos. We take donations. We earn what little money comes into this is either through donations, hopefully in the future grants, and doing some training events. So I'm doing a training event next week that was commissioned, and I'll leave the revenues from that in the company to basically pay for its very meager expenses. But this is an interesting idea of what you do to keep a project going after the main sources of support have expired. Reason 5, we're academics. Trust us. There's a little star here which says, but verify. I mentioned this already, but all of our functions are referenced and all of them are tested. They all have bibliographic references to sources. And whenever possible, when a source gives us an example, we include that example in the documentation or in the tutorial, which means if someone says, this is how you compute readability for this paragraph in an article from 1952, we're going to make sure that we use that as an example to try to match that. Some of these methods were developed by us. And there are scientific papers that explain everything about its development and its application. We also have a heavily academic user base, and these people regularly question our approaches, and they help us to improve them, but we're having this used by people who really know what they're doing, in many cases more than we do. So whenever we get it wrong, we get told right away that it's wrong. And this is good because it means that you can trust what's in the package. And this is what open source is supposed to be about. There are no black boxes. And the other thing is, I would say, we don't just write this, we're also the users of this package. I use this in my own work all the time. I use this in teaching all the time. So when we don't like something, we fix it because it drives us crazy. I think this is what makes RStudio so great. It's that this isn't being developed for other people. Those people who use RStudio day in and day out. So if they want something to be changed to make it better, it gets changed and then it becomes better. The other reason is it works really well with great packages. So this is, I think, the last reason. We want this to not just be something where you have to decide that, this is going to be your camera and it's only going to work with Sony lenses or whatever, but we want something that works very well in the overall ecosystem. So our core objects are basically overclassed versions of basic R objects. So when you have a corpus, it's basically a character vector. A tokens or a dictionary is a special type of list. A DFM is a special version of a sparse matrix, and it's capitalized here because it comes from the sparse matrix package, which means if you're developing tidy models for sparse objects, you can very easily unclass the DFM or unclass the DFM part because it's just basically a sparse column matrix. TextStat objects, all of them are data frames, easily converted to tibbles or just used as data frames. And all of our text model objects are written based on for better or worse, the core objects in R, like linear model objects or generalized linear model objects. They all have methods for predict, for summary, for coefficients, and for printing. So if you're familiar with how to fit a linear model, you should be familiar with how to fit a text model. We also have a really good function called convert, which converts a DFM into any format that you want. A data frame, although we don't recommend that because it's not sparse, a TM sparse document matrix, topic models, objects, LDA, topic models, STM, back when people were inventing creative ways to represent sparse matrix objects for inputs to topic models, we can convert to all of those, or objects for inputting into the latent semantic analysis or LSA package. So you can use quanteda and very easily get the results and then take over for another package. So it works really well for handing off to text-to-vec. Our FCM can go directly into text-to-vec to fit, say, the glove model for estimating word vectors, or to the STM package for structural topic models, wonderful package. Our DFM works directly on a DFM. I'm sorry, their STM function works directly on our DFM because we actually contributed code to make sure that that works. You can use our token streams for inputs to Keras, for advanced neural network deep learning models. There are translators for tidy text. There are some things built into tidy text that work directly with DFMs to and from. And you can use foreign tokenizers, which I already mentioned. If you want to use TM, then there are translation functions for most TM objects. But I don't think there's only one function I know of in TM that quanteda cannot do, unless they've sneaked some stuff in recently. And that's the stem completion. But why would you need a function to replace something that you chopped off? We are also designing this to work very well with the tidyverse. So the pipe operator is re-exported since the very first version. So I see sometimes people will load all of dplyr just to get the pipe operator. That's not even where the pipe operator is written. It's written in Magrittr, but we re-export it from Magrittr. We also have this quanteda tidy package, and that's growing. And the other things are from the previous slide and shouldn't be on here. And then the last version, the quanteda universe keeps on expanding and expanding. And if you've seen this, this is from the Monty Python's Meaning of Life. We got Star Wars and Monty Python in here. The ecosystem looks like this right now. We've got quanteda in the middle, We've got quanteda text models that were pulled out of quanteda. There's a read text package, which allows you to basically feed it any form of document and it converts it to plain text and reads it in. I just updated this package 2 days ago as well. We've got a package for doing annotation, which works very well with quanteda or standalone. The color scheme here means if it's dark blue, you can use it standalone. So stop words, we had a stop words built into quanteda, and so many people were using them that we made it its own package. And this has nothing, it works great with quanteda, but you can use it totally separately. Our most downloaded package of the entire ecosystem, in fact, is the stop words package. Quanteda text models requires you to use quanteda, so you cannot use it without quanteda. And then we have these gray ones that are in development that are not published on CRAN yet, either because I don't want to get sued by someone whose dictionary I'm still trying to work out permissions for, or because they're too big, like quanteda corpora is just too big for the CRAN guidelines, or they're under development like quanteda tidy. And I should have added quanteda sentiment here. That's not actually on the list. If you want to check out more on quanteda and you haven't already, click on this link, quanteda.io, for more. If this were actual YouTube at this stage, I'd be saying, and don't forget to hit the subscribe button, but it's, I guess you can subscribe to the YR channel. I'm not going to show you some examples because that brings us up exactly to 40 minutes, and I want to leave plenty of time for questions. So I'm going to leave it there. And I hope that you have enjoyed this walkthrough and that you're completely convinced now that you want to stop using other text analysis packages and embrace quanteda now.
Thank you for your presentation, Ken. It's really amazing, and I must admit the work of the quanteda team is very impressive, especially considering how hard it is to do a professional software development in the academic setting. I'm fully aware of the limitation of the setting, and I'm sure we will talk about this. But first and foremost, let's talk about questions from our audience. And the first question is about the tuning of the models. So one of our spectators asked how to tune quanteda text models. Is it possible to integrate quanteda models into Caret, MLR, or Parsnip setting for tuning?
Okay, so at the moment, integrating them into those packages for tuning is possible, but you'd have to create the code to do that yourself. But when I said we're a little bit conservative on the way that we put things into quanteda, let me give you an example. So we have the fastest naive Bayes implementation for sparse objects that you'll find anywhere in R. And I know this because I did tests on all of them and made sure that we were faster. By default, you get a multinomial sparse naive Bayes implementation. There are only two options there. There's one for your priors. You can set the document the class priors, and then there's the distribution. So you have a choice of Bernoulli or multinomial. You don't need a Gaussian. So we could implement the Gaussian if you had weighted your features in such a way, but Gaussian distributions, which is the default, for example, in E1071, is not a feature of non-negative count matrices. It shouldn't be using it. It gives you the wrong results, actually. And I've published blog posts about this, or Stack Overflow answers. So when people talk about parameter tuning in a model like naive Bayes, there are no parameters to tune. There's only feature selection to tune. And there are, of course, there are many models where you've got all sorts of parameters to tune, but that's not one of them. There is, of course, support vector machines, another popular supervised classifier. What we did was we figured out we did a lot like what we did with naive Bayes. We figured out what type of SVM is appropriate for non-negative count sparse objects. We took the two that we liked the best, we put those in the quanteda text models, and we sort of fixed that to have a linear kernel because that was the most appropriate for text. So if you want to use SVM from any other package, of course you can, but if you want to use one that's sort of been designed to follow best practice for the most appropriate type of model, you use that. And I think there's only, we passed through one or two parameters that relate to how it's fit, but there are not that many options that you need to fix. So in most of quantita text models, this notion that you would have something really complex where adjusting the knobs and dials gives you different outcomes, you actually don't need that in the ones that are implemented now. And where the ones that you do have that, like with the logistic regression, which is just passed through to GLMNet, through the ellipsis, we implement the ability to pass those arguments through. So this notion of, people ask about tuning the text models. There's not that much to tune because they're sort of already tuned.
Thank you for your answer, and I think that's pretty much it. There's really very, very little to tune, and the feature selection is always problematic to tune because you have this even if the larger amount of features, of course, always tied to the better performance. So any typical performance optimizing method will always be biased towards the large number of features. So Ken, our audience was really curious about the compatibility of quanteda with other with other packages as spaCy, text2vec. And of course, you showed this through doing a presentation, but for example, could you talk a little bit about how quanteda works with spaCy R?
Right. So I developed spaCy R with Aki Matsuo because we wanted to solve a problem of how to get annotations for text. And also spaCy has a brilliantly smart tokenizer, especially for sentences. It's really wonderful in some of the more advanced models for tokenizing things that is smart in a way that the Unicode-based recognition and the lookup tables for words that don't have white space tokenizers, like there's actually a table in Korean for figuring out what words signify the end, what characters signify the end of a word. The way spaCy approaches that is totally different. We wanted to make use of that. So we wrote this package, which we put into a standalone package. When you feed a text to spaCy R, it uses reticulate, it calls the Python library, it runs spaCy, and it returns a data frame. It can also return a list if you just want to use tokenizer. And in this data frame or list, you can get annotations for parts of speech and other things. You could then take that information and use it in whatever you want. But we've got functions that recognize this object that will automatically create a tokenized, a tokens object in quantita from that annotated spaCy object. So it works perfectly with spaCy. And very often what I do with my text is I don't use quantita's tokenizer. If I need something, I'll use quantita's tokenizer until I'm ready for the final result. And then I'll replace that with spaCy's tokenizer because it's just a little smarter. And if I need parts of speech, I have to use spaCy's tokenizer. It's really, really useful and very well integrated. And you'll see examples of how that works on the documentation. spaCy is a quite simple package because it only has 2 or 3 functions for sending things to spaCy. So that one's an easy one. The other question was about text2vec. So text2vec takes what is a feature co-occurrence matrix. It's a feature by feature matrix. And it's created counts based on a local window of co-occurrence. And you can apply weights. For example, the standard algorithm would apply a series of inverse weights depending on its location to a target word. But it's a fairly complex algorithm of going through a text and counting how many words co-occur within that window. So we wrote a function to create this called FCM. And we have a tutorial on the quantita.io website, which is about word embeddings and using text2vec with quantita. You'll see how simple this is. You take your text, you create an FCM, and you feed that directly as an input into text2vec. That works because the FCM is a special class of DFM, which is a special class inheriting from the sparse column matrix object from the matrix package. And that's what text2vec takes as an input. So it works directly.
Thank you very much, Ken. And we have also a question about sparse matrix support, and I want to precise it a bit better. So As far as I know, the sparse matrices are implemented in three ways in R. There is a quite heavy package matrix with capital M, S4 classes, and so on. At least in my experience, not that easy to use. There is a very lightweight S3 package SLAM, which I recommend to everyone. And there's also a bioconductor only package Matter, which is very efficient in the sparse matrix manipulations. Actually, I think the most efficient right now, Matter by KLBM is I'm not using it, but it's definitely one of the options on the market and seems like to be the most optimal right now. So what quanteda is using for sparse matrices and why?
It's using the matrix package because when we wrote it, it was more modern and more flexible and more efficient than SLAM. I don't know anything about the Matter package, but I know that matrix. So the matrix package, the thing that puts people off is not so much, I think, anything about how it works as how it's written. And it's written in S4. And there are a lot of our users, as soon as they see S4, they say, okay, I don't want to go there. S4 is not that bad, actually. It's a much better attempt at a class system that makes more sense than S3 in many ways. It uses what you'll see in Hadley Wickham's book about package writing or about advanced R. Basically, he says, there's this thing called multiple inheritance. Stay away from that. It causes more grief than it's worth. Well, the matrix package is actually a brilliant example of proper use of multiple inheritance, where a child class can have multiple parent classes and inherit properties from multiple parent classes. So we actually, I think I spent like a week of my life with a giant whiteboard, kind of like this big blank giant whiteboard, where we mapped out all the classes and on the relationships in the matrix package, got my head around that. It all boils down to, essentially, there are two major ways to represent sparse matrix objects. One is a triplet representation, where you keep a track of the X and Y coordinates of your cell and then the value that's recorded in that cell, and you only do this for non-zero cells. Or you can have what's called a sparse column or row representation, where you have not the XY coordinates, but you have a marker that tells you when a new column or a new row has been reached. You have the same X representation, but it's a little bit more efficient. Matrix uses that, and a lot of people, at first I had trouble getting my head around that, but once you learn how that works, it's actually not that hard. It's more efficient in space and computation. Also, there are translators, so you can use the as S4 function to go back and forth between the triplet and the sparse column, which is the R. Everything in R is major column major, built around columns. So it's the sparse column matrix. But in essence, these things don't matter that much, because a DFM is technically speaking, it's a sparse column matrix from the matrix package. You can easily convert that into any other sparse object you want. You can convert that to SLAM. You can convert that to, I'm sure you can convert that to Matter. If people had trouble doing that, they would write a feature request. They'd say, add this to convert. Put an option in convert for SLAM or Matter, and it wouldn't be hard to write.
That's really amazing, and I fully accept your defense of Matrix. Definitely, this package was always more mature and more robust than SLAM. True that. So, another question from the audience. Is it possible to implement lasso regression or ElasticNet using quanteda?
Yes, it's already implemented in the text model _LR. Now, I can't remember if this is on CRAN yet or whether it's in the version about to be updated for quanteda text models. That is a straightforward wrapper around cv.glmnet for logistic regression, which is basically lasso for logistic regression.
That's amazing, Ken. And that actually moves me to my to my very last question. It's a soft one. So quanteda is a large project. It's a collection of packages with a lot of documentation, a lot of internal compatibility and external compatibility. This project is, in my opinion, a big effort, an effort that normally only business is able to produce. How are you managing to develop software on a very professional level, starting from academia? How to do this?
Um, you need sort of smart, highly committed nerds, and it's more than that though. So first of all, you have to be really, really lucky, like I am. I have a really good job, London School of Economics. They support me very well. They support my activities. They support part of what I do. I mean, I have a lot of teaching and other things to do, but we have a certain amount of our job is for research. Now, if I were a junior person trying to get promoted, I would need to produce articles in the standard journals, and I would need to have those articles receive citations. That's how you rise through the ranks in academia. It's also how you get a job in the first place. Fortunately, I've done that, and I'll be honest. I did not start this project until I was already a full professor. I do advise junior colleagues. Contributing to open source is wonderful, but don't neglect your standard research career, because that's how you'll ultimately be judged on for promotion. Things are changing a little bit though. You do get more credits. I mean, if I got a credit for every download of quanteda the same way I do for a Google site, I would have more citations than Karl Marx. But that's not how people count downloads. So I would say, how do you get started with this? Well, first of all, I don't know, 10 years ago, I was not really very good at R, and I didn't know anything about team programming. I've done a lot of programming, and I was okay at R. Okay, it's not, but getting to that level where you write code that doesn't incur technical debt, you go through several cycles, and we went through several cycles of education where, you learn a lot, and you also have to be part of a community where you can learn from, studying other people's code, other people's packages, attending things like YR, working with other people, working with people that are more talented than you in certain areas. You learn from them, and everyone has different types of talent. So this mixing and learning is really important. Don't work in isolation alone. Best thing you can do is, so whenever no code gets into quanteda, that if I write it, Kohei has to approve it. If he writes it, I have to approve it. And we often have debates over design. We also have debates over, efficiency. And this produces a much, much better product than if it were just me alone. There's no doubt about that. You also have to, in a sense, do the opposite of that, which is you have to have some person exercising an overall vision. So designing software by committee also doesn't work, because you can't, you have to choose a vision and not make too many compromises, especially over things like design. You can implement something, very often we'll implement something where we implement a first version where we've got the design, the user-facing design won't change, and then we write a version that we know is not going to be the fastest, but it works. Then we write other versions that match that improve the performance. So often the performance is the thing to be optimized later. I would say the other thing is, you have to really be committed and believe in what you're doing, because the rewards for this are not, you don't make money directly from open source software. You might make money from people hiring you for consulting. And I think a lot of younger people are motivated to contribute to these projects because it proves that they can do something in a very open way. But for me, the reward of producing this sort of software and for talking to communities like this one, it's a real democratization of data science to give people tools that they don't have to pay for, and that they can see how they were developed and even contribute to. And one of the things I like about, so there are many things that I really wish we were in Warsaw or together in a conference where I could actually see the audience I'm talking to. You could laugh at my stupid jokes, and we could talk in the hallway afterwards. But with this online format, I think it makes it possible for people from wherever they are in the world to attend and to benefit from this in a way that might not have been possible because of the cost of travel or visa restrictions or whatever. So in a way, this move to the online format has even further democratized these resources. And I really like the idea that I'm contributing something that are helping people learn who don't have a large amount of money, or who exist in somewhere where otherwise, they can be a student, you can be a professional, you can be working in a company, you can be working in education, you can be an independent researcher, and these tools are equally available to you. That's a big source of satisfaction. I could spend my time writing one more academic article that might get a few more citations and would be highly appreciated by, say, 12 people in the field, and that my own family wouldn't be able to read a word of. Or I could work on something that maybe, there are hundreds of thousands of people using quanteda based on the downloads, and that's very satisfying.
Ken, we are almost out. We are out of time. So I just want to. So I will skip the very last questions, and we'll just ask one, which is one very last, which is very material also. So how people can support you? Do you have a donation box? Do you have a Patreon? That's what people are asking.
Oh, wonderful. Well, we have a PayPal account. I don't think we have it linked on the website yet. It's quanteda.org. We will hold that thought, and we'll try to put up a button for that. But that's very kind. Wonderful. Great.
I think projects like yours are really inspiring greatness in people, because you are also showing that one could share with them a lot of great things by investing their free time. And I'm very happy that people want to repay for that. It's really amazing. So once again, Kenneth Benoit, Quanteda for YR. Thank you very much, Ken, for being with us. Thank you for this great talk, and I do wish you all the best on this project. Thank you.
Thank you. Bye.
Okay,